from the IQhub. I wanted to talk to you about our second exhibit called the Hopkins patent. And this one talks about some cool innovations in agriculture and the first patent in the United States. As farming practices were improved, simple processes were identified to increase crop yield. Man discovered that by boiling wood ash produced potash, and this helped the soil increase productivity. Samuel Hopkins received his first patent from the United States government when he found that combining potash and pearl ash being the mixture of potash and lime, would increase the nutrition of the soil and be more productive for farmers. Later, Hopkins sold his patent to local companies who built asheries and increased the demand for potash in agriculture. Hello everyone, we're here with Randy and Savannah. We're going to do some lesson activities with trees today.
Yeah?
And so the first thing we got to do is we're going on an adventure and we're going to collect a bunch of different types of leaves and needles and things from trees so we can see if we can figure out what the trees are. All right, Savannah, let's start. Which one are we going to go to first?
That way? This is a good one.
So she's jumping up here. So what she's going to do, show us, Savannah, what you're doing. We're not just going to take one leaf.
We're going to take
Yep.
Hey!
Kind of where it attaches. So the cool thing is you have to have more than one. And you have to kind of see how they alternate on the branch or how they're opposite on the branch. And there's another one she has. Hold still. This one looks like it's alternating too. All right, so put them in the bag. We got 2 trees down. Go to the next tree.
why? There's just the way I know. Across the road.
There you go. So she's pulling it back a little bit farther on the branch.
This one blooms flowers, so this is a
Ooh.
special tree.
Perfect. Put it in the bag.
They're very smelly flowers.
What's this one? Let's get this one.
Randy, come on. How about we go this way? Going.
There you go. You don't need too much of that one. That one's kind of,
Pokey.
yeah. Do you need some help?
Yes.
Okay, there you go. Go a little bit lower where,
Poke's hurt.
right here, a little bit lower where it's softer. Got it.
Yeah.
Okay.
Come on, tree. These aren't the ones you use for Christmas trees, but the other ones are.
Ooh, maybe. Don't you be giving away clues. Put that in our bag.
Okay.
So how many do we have so far?
I have 1, 2, 3, 4, I think 5 different leaves.
Okay, let's find some over here. Let's do this one right here. Can you reach this one, Savannah?
No.
If I pull this one down.
These
Don't tell us what it is.
berry bugs. No. Let's grab some with
Can you
some.
grab one?
Yeah, berries on it.
Now you want to try to take a spot that isn't a big spot
But it
on the
has-
branch. It's hard to break. You don't want to cause damage to the tree. We just want to borrow a little piece so that we can try to do some identification.
They're just so picky about this. This one will not work.
Yes, it will. Pull.
It's pulling all the skin off it.
Let me help you. Let go.
Yeah,
I got
so.
I got
2. I got 2.
Ooh, thank you. Put them in the bag.
Boing.
Here you go. Randy, you want to get this one?
I just found this tree. This is soft bark.
Okay, put it in the bag. Randy, grab this one.
This is soft bark.
Nice.
Randy. Randy. I
They
know, they're
will if you grab a
pokey.
big piece. You grab at the end where they're softer. So when you're looking for trees, guys,
I found a pokey one.
you want to make sure you get a big enough one where you can sample.
Ow.
Gotta get at the
Very
end.
pokey.
And you want to make sure you can get, oh, got it, some leaves and where it is on the branches. Let's go over here and look for some more.
Playing.
All right, we found some more trees. This one looks really complicated.
Oh, these one have the spinny things.
Ooh, spinny things. That's a little telltale
The
sign.
helicopters.
And you know what else? We got to talk about the difference between, put that in there, there you go. single and compound leaves because that looks confusing. All right, Savannah, what about this one? Let's get this one.
This is
Let's grab some of these.
Do we already have this tree? Oh, it changes colors.
Ooh, it does. So grab one little branch there. Remember, if you get towards the bottom, they're not as pokey. Just like a fish, right? You gotta smooth the needles or the scales one way so you don't poke yourself. Alrighty, so we went on a scavenger hunt and we found a bunch of different trees, little branches with leaves to show where they're all attached. And Savannah and Randy picked a whole bunch of different types. So the first thing you guys have to do is make 2 piles, which kind of look alike and the others will look a little different, okay? So go ahead, start making 2 piles. All right, so Savannah's got 2 piles. She's got one that are kind of flat and, what did you call them?
Flat and like a regular leaf.
Okay, regular, soft. And then ones that are like what?
Pokey and hard, and that hurt.
All right, so now we got these 2 words right here. And these are pretty funny words. One says deciduous, and one says coniferous.
But
So these 2 words are different. Which type of leaves do you think is deciduous? Which type of leaves do you think is coniferous?
This one's coniferous.
So we put the pokey ones by coniferous, Savannah?
And
The soft ones by deciduous. Why did you decide that?
because coniferous kind of sounds like it would be pokey, and this kind of sounds like it would be flat leaves and regular leaves.
Okay, so let me tell you like a clue, okay? Take this little highlighter and underline the first 3 letters of coniferous.
I want one.
You can have the orange one. Okay, so con kind of sounds like cone with me, right? Okay, so now this one I don't have a good clue on. DEC. Okay, so here's how I remember it. So con, like coniferous, kind of sounds like cone. And anything that has like a pine cone keeps their needles year-round. They call them like an evergreen. Okay, this one, deciduous. Okay, deciduous, these are the flat, regular leaves you call them, the soft ones. So by December, these trees will have no leaves on them. So deciduous trees lose their leaves after the season's over. So you guys see these ones turning colors in the fall. And by December, there's no leaves on the trees. And these coniferous or conifer trees, these ones are green year-round. You drawing us a picture, Randy?
It's a house.
Beautiful. So now you got 2 types of trees. So when you guys are looking in your yard, you can look for the ones that look like they have needles or they're pokey, and those ones will keep them year-round. Those are called coniferous. And these ones that are soft, flat, they lose them after they change colors in the fall. Those are called deciduous. So that's the first part of the activity. It's kind of fun. You guys can check out these things around your house. Okay, so the next thing that we talked about when we were out collecting was the difference between a simple leaf and a compound leaf. So looking real close, this one could confuse people because people might think there's a bunch of little individual leaves, but that's actually one compound leaf where it attaches right here at the base, has several different little leaflets on it. And then this one is a definition of a simple leaf because where it attaches at the base, there's just one little leaf on it. So Savannah, what did you bring up about this plant?
It has the helicopters. In the helicopters down here, when it gets hard, there are seeds. And in the seeds, I'm guessing, the seeds help make a new tree.
Correct. So the cool thing about these little things that you keep calling them helicopters, pull one off. Helicopters are found on this tree that has compound leaves and this tree that has the simple leaves. So they're related.
This by myself.
1 second, Rand. They're related. So do you know what type of tree this one is?
It looks like a maple tree.
There's a bunch of different types of maples, but maples have the helicopters. And so that is what a maple tree would look like.
On my house too.
We do. And this one is a compound leaf, but has helicopters. So this one is actually related. This is called a box elder.
Whoa.
And this one is called a maple. And they both have the helicopters. They both have the same. If you look close where they're attached, the leaves, that's not a good one to see right there. Let's look right here. See how where they're attached? Move your finger. Right here, they're opposite of each other. So the little leaves are going to attach opposite on the branch. This one's going to be the same way. See how the little leaves right here are opposite? Maple trees are like that. So maple trees are opposite. Okay, let's look at our next type. So we don't really have a simple compound example for this one. But this one was Savannah's favorite, so we wanted to include that one. And this one is my favorite.
A willow tree kind of like hangs like a vine. And if you can have a bunch of them, you can swing on them. They're pretty sturdy.
That's cool. And this one's my favorite. What type of tree is this? Do you know?
These are pokey trees. These are pokey trees.
Kind of confuses you, right? See how this one is alternate? It goes there, there, there. They zigzag. The branches zigzag. That's actually an oak tree. This one's alternate.
Yeah.
This is an alternate branching pattern. And the willow tree does too. See where all the little leaves are? They're alternate. Some people call the willow maybe a compound because they're so complex. You can grab a bunch and swing on. But it just gives you an example of how this one is alternating. And the same with this oak tree. But you're not going to have that in the maple.
This one has like a little bud in between every branch. What is that?
That is a good idea of where we're going to help reproduce maybe more trees. So the buds are real important. And you're going to have buds.
A bud can fly berry hats and can eat berry sass and like that.
Not a bug with a G, it's a bud with a D.
A bud, B-U-D, bud.
Buds make more trees.
Bug.
Very cool. All right, so all the leaves we were just checking out with opposite and alternate budding and branching patterns, those are for deciduous. What does a deciduous mean again?
I forgot.
They lose their leaves, right?
Yeah, they lose all their leaves and but they grow back.
Yep, so come December, they're going to have no leaves on the trees.
No leaves.
But these guys, do you remember what these ones are called?
They are deciduous, which means they have their leaves all year round, kind of like an evergreen tree.
Evergreen is right. The con part is right. Coniferous. You're so close. So these ones have cones. These ones don't have buds. They have cones. So Savannah has these in her hand right now. What do those feel like?
They don't feel pokey like these ones, but they're kind of like a long line on the top. They're not really hard, but they hurt.
Okay, so let me help you out with this. This is a pine tree, and where you look to where these attach, they call that a fascicle. So if I pull one of these off of the fascicle, count how many are right there.
5.
5. So that is a white pine. W-H-I-T-E. 5. White pine. That'll help you remember. There's a red pine. There's a jack pine. All kinds of pines. But pines have needles.
Oh, on the top of the pine tree, it looks like it's a whole nother tree because it's a little brighter. But there's like a stem at the bottom. There's like a stem at the bottom, and then there are less trees.
Okay, so this is a different one. Let's look at this one real quick. Tell me about what you saw with that one, speaking of colors.
This one, near like when it gets thicker, it was a darker color, but when it gets thinner, it was a brighter color.
So pine trees have needles. This one is called spruce. They're individual little looking needles.
They have a lot of them, and they hurt.
They have a lot of them. They're usually sharper. They're shorter. So this is a spruce tree. Okay. These ones are pretty flat. You talked about these ones being pokey, the pine trees, the conifers.
Really
that one doesn't feel so hard.
Randy was going to say, Randy, what did you want to say about this tree?
Planting them make them big and strong.
But it feels like a what, Randy?
Sometimes people can put them down with their hands.
And it
they
feels
feel
like
A big mountain.
a fan.
Fan.
So these flat scales, and these ones are usually called cedar trees. Flat scales are usually white, and they could be like a fan.
Oh, and they're not that pokey.
So you have needles, scales, needles, And these
On
individual,
one side.
1 second, needles and scales, and they're all different for sure. That one's pokey, isn't it?
This one is very pokey. It was hurt.
Yep, my student got cut.
So sometimes they're sharp, sometimes they're soft, just depends. But these ones are conifers, and they don't lose their needles or their scales.
This one doesn't hurt at all.
All right, guys, you know what I forgot to ask you? What are your favorite things to do with trees?
My favorite trees, helping trees get broke or get a broken leg or get a broken root.
So,
I'm a dentist.
so trees help you maybe make crutches? Maybe trees help you make tools for the dentist? Is that what you're saying?
Yeah.
So trees can be very helpful. What do you think, Savannah?
My favorite thing to do with trees is I like to look at the different kind of leaves, and I like to climb trees.
Climbing trees. Randy, you like to climb trees.
I like climbing trees. Every time I see a tree, I climb it.
Got to be careful though, don't you?
Yeah. Sometimes.
Trees give us shade. Trees give us, like we said, build things. So this is a really cool word. Let me see this real quick. This word is dendrochronology. So read it to me, Savannah. Can you read it?
Dendrochronology.
So that's a big word. Do you have any guess what that means? No, me neither until we start studying it, right? Take your first color and underline the dendro part. Big words, if you break them down, they're easier to understand. Okay, next color, the cron part. And the next color is the ology part.
Where's my green?
So anything that talks about ology is the study of. Have you ever heard of words that end with ology?
No.
Biology, astrology, meteorology, anything with ology, right? Okay, so what Savannah just did was she underlined 3 parts of the word. The dendro, Randy.
Cron and the ology.
Yep, the dendro means trees. Chron is for time, like chronic, like time. And then ology is the study of. So it's the study of the age of trees. Crazy. So what Savannah and Randy have right now is a rock. And we made it look like a tree. Sit up here, Randy. And if you were to cut down a tree, you would see what, Savannah?
You would see rings. And if you count the rings, I don't think you include the middle, but if you count the rings, it tells you each ring is a year. So if this was a real tree, it would be 1 year, 2 years, 3 years, 4 years, 5 years, 6 years old.
Very good. Yep, chronology, dendrochronology is the study of the age of trees. And it's the rings. And you're right, you don't count the very center. The very center is like the starting point. You don't count that. And then the very edge where the bark is, the shaggy line I made is the bark. So count the rings out from the center dot, Savannah. And do you still get 6?
1, 2, 3, 4, 5, 6. Yep.
You're not counting the bark, right?
Oh, no. Don't count. 5.
5. What about this one? Randy, can we count the rings on this one? Savannah will help you. Start at the middle.
1, 2, 3, 4, 5, 6, 7.
5. There's 5.
Okay, let's do it together again.
1.
Randy, count.
1, 2, 3, 4, 5.
6.
Just 5 because that's the bark, right? Are both these trees 5 years old?
1, 2, 3, 4, 5. Yep, mine's 5.
So wait a minute. If they're both 5, neither one is a perfect circle.
Sometimes this one's
So
big
they're
and
not-
this one's not.
They're not really they're not really a perfect square, so there might be, if this was a real tree, it might be 6, it might be 7, it might be 5. You never know.
So it depends on when they start growing. If these 2 trees were the same type tree, let's say they're both maple, right? Even though they're not perfect circles, even though they're not the same size, look at the rings are even different shapes. It doesn't matter. Maybe it's something to do with the environment. Maybe they're crowded. They don't have enough sun, enough water. So dendrochronology is the study of the age of trees. Okay, so here's our little maple tree again. Remember that leaf we found? Randy, do you think you could count those rings with Savannah?
1, 2, 3,
No,
4.
not the leaves.
Oh, we do have a lot of leaves, but what I'm trying to say is,
3.
look at all the rings on that. How hard would that be to count?
1.
You're counting the leaves, right?
give him a bag.
Here, Randy, here's another type of tree. This one's like a poplar tree.
No,
Can you count those rings?
I can't.
This one's really hard.
They're too hard. No.
Okay, then we'll save it for Savannah.
104.
Good golly, see there's a lot. I don't know if there's 4 there.
104 leaves.
This one's a hickory tree. Look at how different this tree is to this one. You're probably not gonna be able to count them all as fast as we're going, but look how much the color changes.
Yeah, and the rings are getting thicker.
Which one's easier to count?
This one.
So sometimes darker woods are easier to count. Sometimes if they're more healthy, the rings are more pronounced. These ones are both kind of hard to count, but I would agree that one's probably easier than the other one. Okay, so get the, what is it, hickory and maple out of the way? Look at this big one. Did these leaves
That's
tell
like
you?
1,000 years old.
Did these leaves tell you what that tree is? What's this tree?
Oak.
See, there's those leaves again.
This is probably, I'm estimating. So this is probably, I'm guessing, 100, 200 years old.
So trees can live a really long time, and the scientists can go around and study all the rings. Look at this one. This is a different one Randy had. They can count all the rings, but what if they have a hard time seeing the rings? So sometimes they can use a tool or like a magnifying glass, some way to see the lines. Or you can actually measure how wide the tree is and learn how old it is maybe by how wide the tree is. But that's more of a guess. Because trees could be different sizes, right? These two are the same tree and look how different they look.
These two aren't the same tree, but that's why they're still bigger.
So we're not telling people to go around chopping down trees, but if you guys heat your house with wood, or if you have trees that fell down in your woods, check out dendrochronology. You guys can go count the rings, have some fun, ID some trees, and get outside. What do you think, Randy?
Can we get up?
You want to get up now?
Yeah.
Okay. Thank you. Bye-bye.